Hello everyone. In this hands-on tutorial, we'll build a real-world cloud architecture from scratch, perfect for developers, cloud engineers, or anyone learning AWS. We'll start by creating a custom VPC to isolate our environment. Inside this VPC, we'll add two public subnets for hosting web-facing servers, two private subnets for feature backend or database resources, an internet gateway to allow outbound internet access from public subnets, a route table to make connection between public subnets and internet gateway, and a NAT gateway to create a secure connection between private subnet and public subnet and allow private subnet to access internet and reduce the risk of attacks. Next, we'll spin up two EC2 instances in our public subnets for high availability and minimizing latency. To distribute traffic across these two servers and make our system more reliable, we'll configure an application load balancer for these two servers. To improve performance and add an extra layer of security, we'll place a CloudFront distribution in front of our application load balancer. And to track web access logs, we'll collect logs from our web servers and store them in S3. So let's get started. Before we touch any of AWS services, let's follow best practices and avoid using root account. We'll use an IAM user with necessary permissions. For that, let's go to IAM console. Type IAM here, go in IAM. First, we'll create a user group, create group, grp01, let's name this. And then we'll attach permission policies. What are these? Is that which services this user group can access and what it can do with those services. So for our use case, we need VPC. For simplicity, I'll give full access. We need EC2 full access, and then S3 full access. We need Elastic load balancer, and we need CloudFront. And these services actually need to access CloudWatch, so I'll give that also. CloudWatch full access. Create user group. Okay, now we'll create the user. Create user. Let's give it dev username. We'll give them management console, and I want to create an IAM user. When you click this, you'll get an auto generated password, but the user must create a new password in the next sign in. So next, we'll attach this to VPC group so that it has all the permissions that this group has. Next, so when we selected new password on the next sign in, it gave it a permission that IAM user can change password and all the permission policies from our group. So create users. Now these are the credentials for our user. Let's copy the sign in URL and let's download the CSV. Now let's sign out of our root user, sign in back with our IAM user. So the account ID would be in the CSV file that we downloaded. So in the URL, you'll find a number like this after HTTP, and that will be your account ID. IAM user, we can give dev user, and the password is in the CSV file. So I just copy that here and sign in. It will ask for the old password. Again, paste it here. New password. Let's create that. And confirm password change. Now we have to continue sign in. So now we are in our IAM user and we can start creating our resources. But first, let's change our region to North Virginia. Inside this North Virginia, we'll create a VPC. Create VPC, give it a name, let's say VPC01, and the CIDR block we'll give 16. Create VPC. Now inside this VPC, we'll create a subnet. That will be a public subnet. Select the VPC. subnet 01. Availability zone is 1A, and in the CIDR block for this VPC we'll give till 24. Create subnet. Now we'll create another subnet in the same VPC, naming it as public 02. Availability zone, let's keep it B, and this should be 1.0 from 16 till 24. What happens if I give it 0? It will not allow, so we have to keep it 10. So we have our both public subnets. Same way we can create our private subnets. Let's keep it on a different availability zone. It won't allow, so we'll create it on 2. Subnet 02. That will be on a different availability zone. 0/24, and we have all our subnets ready. Now for internet access, we'll create an internet gateway. So create internet gateway. Let's give it internet gateway 01. Create it. We have to attach it to our VPC. VPC 01, attach internet gateway. Now for attaching internet gateway to our subnet, we'll use a route table. So let's create a route table. RTP01 in VPC this and create route table. Okay, now we will edit routes and we'll add from all traffic to our internet gateway. So edit routes will attach our route table to our internet gateway. For attaching our route table to our subnet, so we have a connection between these two, we'll go to subnet association and edit subnet association. We will do that with our public subnets because we don't want our private subnets to be attached directly to internet gateway. So save associations. Now we have a connection between our subnets and internet gateway via route tables. Now we will create a NAT gateway. Create NAT gateway. Let's say NAT01. Subnet is our public subnet 1. Okay, we'll create connectivity type as public, and we'll allocate an elastic IP. Create NAT gateway. We have created our NAT gateway for our public subnet. The status is pending, so it will take some time to create. As we can see, the subnet that it's connected to is public subnet and the VPC is VPC 01. Now our VPC is ready. Let's create EC2 servers. Just open it in another tab. EC2. Launch instance. Server name is, let's say, VM01. Okay, I'll use Ubuntu machine, and instance type is T2 micro. I don't want to pay, it's free tier eligible. Key pair, I have my key pair, so I'll select that, and I will edit the network settings because I don't want to use the default VPC. I want to use my custom VPC. In the public subnet, let's say I'll create public subnet 1 first, and I want to access it via HTTP, so I will enable the public IP. Create a security group. Let's call it all, and I will add another security rule that will be HTTP from anywhere. So it has opened the port 80. In production environment, we'll be using HTTPS, but for simplicity, let's keep it HTTP for now. We have configured the storage and we launch the instance. So our first public subnet EC2 instance is created. Next, we'll launch a dummy Amazon app in this EC2 public server. So we go to our EC2, go to connect, click connect. But wait, we don't have access. Why? Because when we created our user group, we gave EC2 full access, but EC2 instance connect is a separate policy. How to resolve this? We'll again log in with our root user in a separate browser. We'll log in with our root user. We'll give our password, sign in. I have MFA, so I give my MFA code and I am in my root user. Now in the IAM, in user groups, I'll go in VPC group 1 and in the permissions, I'll add a policy which will be EC2. Let the policies load. Instance connect. It's loading the policies. We select EC2 instance connect, attach policies. So we have attached the policy to our group, so our user will automatically have this policy. Let's refresh this. It's establishing connection. So what we are going to do is we are going to create an Amazon clone so that we can access it over the internet. For that, I'll just do sudo -I and apt update apt install nginx -y or -y. Okay, for this clone, for the app, we'll clone a Git repository, and for accessing this clone of Amazon over internet, we have to put it in a folder that's var www./html. So we place it in var www.html. Okay, now we go to our EC2 instance, we copy the public IP, .http, and we give the public IP, and we see the Amazon app is loading, but we see that it's not loading very fast. It's taking time. For that, we'll add the CloudFront, but that's a later thing. So we are able to access that. Similarly, we'll create another instance. We go in instances and then we launch another instance. This is VM02. We select Ubuntu, AMI is done, instance type to micro is good, AWS key, and then in network settings we choose our VPC01, public subnet 2 is good. We need this enabled because we want to access it with HTTP traffic. Okay, we can rename this HTTP traffic. Security group can be HTTP from anywhere. Now all the manual thing that we did for launching the Amazon clone, we can actually create a simple script. So we go to advanced details, and in the last we add a script with all the steps that we followed, and we tell it that this is a bash script that will run on terminal. So we add this particular line and we launch instance. So let's see, and another instance is also created. So we go to instances and we have, this is a terminated one, to forget about this. In this v2, this is still pending. Okay, so let's go in here. Why is it pending? Because we have a script that runs when it is initializing. HTTP do this. You see, it's actually initializing. That's why it's taking some time to load, because it will first run that bash script, install nginx, clone the Amazon app, and it's not able to reach. So let's wait for a few more seconds, and we have our Amazon app. So we have launched two instances that are running the Amazon app together. Okay, here. So now how do we differentiate that which is launching from which? We can either look on the IP address, or we can do something about this header. If we mention that this is the 01 and 02, then we'll be able to tell that which instance is running this. It will help us when we build our load balancer. So let's do that. So for our second instance, let's connect. And what we are going to do is vi/var/html, not html, www, html, and index.html. So here we have a title. I press I to insert, and then we can say 01. Okay, press escape, :wq. It's a read only, so I have to do :q this. I forgot to log in as a root user. vi/var www html index.html. Now I'll go back to that position, press I to enter in insert mode, 01, escape, :wq, and this is there. Now let us refresh this second one, because we are on the second one. Or did we change the first one? Oh, we changed the first one. Right. In the instance, let's go in VM2 and let's connect. Established connection. We enter in sudo user and then vi/var/www html index.html, and we do what? We go to title I02 wq, and then we go in here, refresh this, and we get it as 2. So we know that this is coming from server 1, this is coming from server 2. Now let's say that a lot of people are accessing our Amazon app through this particular subnet, and a few people are accessing on this. What will happen is that this will be underutilized and the other one will be overwhelmed, and there is a chance of crash. How to avoid all these things? So for that purpose we create load balancers. So in EC2 we can go in here, create load balancers, create load balancer, application load balancer we will be creating because we want to access our app. So ALB01, we have it internet facing because we want to balance the application access over internet. In network mapping we select our VPC and we select our public subnets. EC US East to A1 and US East 1A and East 1B. In the security group we can select all, and that's fine. Default is already there. all will have HTTP also. Default will only have SSH. So we have our HTTP, and we can add an additional layer of security with Amazon Web Application Firewall or Amazon Web Application Firewall plus CloudFront. We are not going to add this for now. And I missed this. We have to actually add this to a target group. What is target group? In this we mention the instances that we will be creating our load balancer on. So let's say TCP01, HTTP is good, our VPC is good, and next. So which of these two servers, VM1 and VM2, we want to create. So we include that as pending. So it will target these two. We created target group. Okay, so both of them are healthy, and we refresh this so that it appears in our drop down. So we have target group selected, create load balancer. So the status is provisioning. It will take a couple of seconds or even couple of minutes for activation. Refresh this, and now it's active. So let's go and load balancer, and now we can access our Amazon app from our DNS name itself. So let's copy this. Let's close all the other tabs. Open this and http / enter. So you can see it's on 01. Okay, now when I refresh this again 01, now it's on 02. Refresh this 01, 02, 01, 02. Why is that happening, that on every click it's going to the second one and another click it's going to the first one? Why? Because by default this uses an algorithm for diverting the traffic that's called round robin. Round robin algorithm will move from one server to another server for every request. How can we check that? Is go to target groups, in target group attributes, and you can see here load balancing algorithm is round robin. So round robin, every click it will send on to the next available server. If there was a third server, it would be 1, 2, and on the third click it will be on 3. So that's how this works. Now we have our load balancers in place, and we have reduced the overwhelming of servers. But what about the latency? Now, as we know that Amazon will be accessed from global locations. So we might feel a little lagging. A lot of users accessing this kind of services or web applications might feel lag. To avoid that, what we do is we have another service called CloudFront. What CloudFront does is that it provides access to content delivery network from edge location. Edge location means that from whichever region it's accessing, that this particular app will be available from an edge location of that region, making it faster availability for the users. So how do we do that? We create a distribution, and we can say TST01. We want a single web app, and we want to create it on the load balancer. So we browse the load balancers, we select our ALB, okay, we create a custom origin settings. Why? Because we have only enabled HTTP and not HTTPS on our servers. We can have an origin shield. This will give us extra security. And where would we want that? We want it on our North Virginia, because that's where our load balancer and our servers are. We keep all the default settings as it is, and we go next. We don't want any additional security for now, No, because it will add a WAF. We have seen WAF in load balancer, so WAF is also available in CloudFront. So we do not, and then we have it, and we click on create distribution. So as soon as our distribution is available, you can go in distributions. As it changes from deploying to last modified, it's ready. So we'll click on this and paste it here, and we can have our application from edge location. So click on this. So anywhere, this is a global service. CloudFront is not uh, like, as you can see here, it's not particular to any region, it's global. Why? Because it actually serves the web app from edge location nearer to from whichever region the user is accessing the web app. Now, to track our web access logs, we'll collect these logs from our web servers and store them in S3. Why do we need to do that? Because on these logs, analytics can be performed, security threats can be accessed, and a lot of different teams can do whatnot. For that purpose, first of all, let's create an S3 bucket. Go in here, in S3, let's create a bucket. Let's name it Amazon Home App Bucket. Create bucket. Inside this, let's create a folder called logs. Create the folder, and let us copy the S3 URI of this. Let's open one of our EC2 instances. VM1 will do, and let's connect. Okay, so for copying the logs from our EC2 instance to S3, we'll need a service of AWS called AWS CLI. So do we have it available with us? Let's say AWS version and command not found. So we need to install it. So what we do, sudo, because this is not a root user, so we use sudo, and we use snap info. No, we use snap AWS CLI. So copy this and paste this. But we do add another flag, and that is called classic. Why? Because classic will need to access system resources that's required for copying. So we have our AWS, but we do need to have our EC2 instance know the credentials of our IAM user, because that's how this IAM user will be allowed to copy anything from EC2 instance to our S3. But do we have those access keys? No. Did we create those access keys when we created the IAM user? No. So first of all, let us do that. Let's go to the IAM user, and in users, we go in dev user, and we go in security credentials. So we generate the access key. What we will be using it for? CLI. I understand. And here is my access key and my secret access key. I always download CSV for recovery. Now what am I going to do is, I'm going to copy this. I'm going to come over my EC2 instance, and I'm going to type AWS configure. So it will ask for my access key. I'm going to paste that, enter. I'm going to get my secret access key the same way. I'm going to paste it here, enter. And by default, the region it's giving me is US East 1. If it's not giving, just write US East 1. Now output format, I can have JSON. Okay. Now my AWS CLI is configured for my IAM user. What am I going to do next is that I am going to write a command AWS S3 CP. That means use the AWS command. Which service I'm going to access is S3. What is the action that I'm going to take is copy. From where? From our var log nginx access dot log. To where? To my S3 bucket. In logs, I copy the S3 URI and I paste it here. So S3 in this bucket, in this folder. Let's see. So it shows upload. Let's go in here, refresh this, go in logs, and we have our access logs with us. Okay, so this is how you copy your logs from your EC2 to your S3 bucket. Sure, in production environment, logs to S3 copy are done in real time via automation, and we created two EC2 instances manually, but that's created only once and replicated via AMI. We also create snapshots for disaster recovery of EC2 instances, but all this in upcoming videos. And that is it. We have created a scalable, secure architecture from scratch using AWS core services. Now, before leaving, we should always delete all our resources that incur charges, and even like resources like VPC that don't incur charges, we can clean it up. Let's start with S3. So we select this bucket, empty it because we cannot delete a filled S3. We permanently delete, exit, select it again, delete it. Delete bucket. So we have deleted our bucket. Now our EC2 instances. Okay, before that, let's go to target group and action delete our target group. Target group is currently utilized, so we cannot delete it. First of all, we'll have to delete our load balancer. Let's delete load balancer, confirm, delete. Load balancer is deleted. Then let's delete our instances. So this is running, we just have to terminate this. Now let's select the second one also and terminate this. So both of them are in shutting down. So after they have shut down, we'll delete our target group. Before that, we can actually delete our CloudFront till this gets terminated. So let's go to CloudFront, and CloudFront is disabled. Okay, after you disable it, it might take a lot of time. So see, this is disabled and the last modified is deploying. So when the last modified changes to a date, then you can delete it. So unless that happens, it's in the process. So let's get back to our EC2 instance. This is connect. Let's close that. Our EC2 instances, I think that would be terminated now. Now let's try and delete our target group. Let's see if it creates any problem or not. Deleted. So we have cleared up our EC2 and our CloudFront and S3. So now let's go to our VPC. VPC has a lot of interconnected components, so we have to be smart about this. So first of all, let's clear up the NAT gateway. Okay, we click on this, we delete the NAT gateway. Okay. The thing that we created in last was NAT Gateway, so we deleted it first. Then let's delete our subnets. Two public subnets, actions, delete subnet, and we write delete. Okay, it is showing subnet have network interfaces and cannot be deleted. So we cancel this. We have to first go to our route table, select this route table, and in subnet association, edit subnet association. So we disable the association, right? And since we are here, let's go to edit routes and remove our internet gateway connection from the route table. So this subnet is now removed from the route table. So let's go in our subnets and let's delete the subnet. So you see now it's not showing any warning. This is Amazon Q. I have not taken that, so it's showing that. Okay, we want to keep our private subnets. We don't want to do anything with that. Internet gateway. This action, and we can say detach it from our VPC. So we have detached internet gateway from VPC. Route table. Can I delete this route table now? Delete route table. So delete. So this was our custom route table that we created. There will always be a default route table available when you create a VPC. Just like if you go in here, and this is the default VPC that's available by Amazon. So this route table, there is another route table that is attached to this default VPC. So we go in VPC and we select our custom VPC and we delete the VPC. Okay, so it shows that this will be deleted, and because we have our private subnets in our VPC, these subnets will all be deleted. So for now I don't need that, so I can delete those subnets also. Delete this, deleting subnets, deleting VPC, and now we have clearly deleted our VPC. If we go in route tables, you see the default route table that was attached to our custom VPC is also deleted. Next, our IAM user. Come to our IAM console in another browser. First of all, let's delete our user group. Select this. Sorry, delete users. Delete. So we give the name 01. Delete it. User group deleted. Then users. Create. Delete. It already has an access key. Okay, so we go in user. We can deactivate from there also, but let's deactivate and delete it. How do you do that? In access key action, deactivate. First deactivate it, then delete it. So we have to paste our access key. Delete. So we have deleted that. Now we go to users, select this and delete this. Now it's not showing any warning or error. Delete users. So that's it. We have cleared up all our resources and the user. If you found this helpful, drop a comment, connect with me on LinkedIn, and please share this with someone learning cloud. Thanks for watching and see you in the next one.